Hello grade 9s and welcome to the second exam practice video in which we will be factorizing algebraic expressions. Now again, what makes these problems special is that you will be required to use more than one of the techniques displayed to the top right hand corner of your screen in order to factorize these expressions as far as possible. There are 3 problems displayed to your screen. I would like you to try these problems on your own, so go ahead and pause the video, and as soon as you have finished, continue to watch so that we can work through these problems together. I hope that you enjoyed factorizing those expressions on your own. We will now work through them together, starting with question A, which requires us to factorize 7x to the power of 8 minus 7. As always, we start off by identifying a highest common factor, which is easy to find here because we have a constant and a coefficient in front of the x to the power of 8 that are both divisible by 7. X is uncommon and therefore will not be part of the highest common factor. So we write down the highest common factor, which is simply 7. Now we will take each of the terms in the original expression and divide them by 7. When we say 7x to the power of 8 and divide it by 7, we end up with x to the power of 8. And when we say negative 7 divided by 7, we end up with negative 1. And we write this inside of a set of brackets. At this point, we are done taking out a highest common factor, and we can move along that list to the difference of 2 squares, also known as dots. Do we have a difference of 2 squares? Well, we have 2 terms contained in the set of brackets that are separated by a negative sign. The first term is x to the power of 8. And what you should realize is that we can obtain x to the power of 8 by saying x to the power of 4 to the power of 2. We can obtain 1 by saying 1 to the power of 2. Therefore, both of the terms are perfect squares. So we can factorize that set of brackets by using the method, the techniques that we've learned about the difference of 2 squares. We start off again by writing down that 7. Remember, it's part of the factors that we are factorizing out of the original expression, so please do not forget to write that down. We then write out 2 sets of brackets because we will now factorize the difference of 2 squares. Contained in the brackets, we will have different signs, a plus and a minus sign. Now, to get x to the power of 8, we simply say x to the power of 4 multiplied by x to the power of 4. And therefore, contained in the 2 sets of brackets as the first term, we will have x to the power of 4. To obtain 1, we say 1 multiplied by 1. And based on this, the second term in each set of brackets will be 1. Now, we are done factorizing the first difference of 2 squares, but if you look carefully, you may be able to notice that we have another difference of 2 squares, because we have 2 terms that are separated by a negative sign, and of course, the terms are perfect squares. As always, we start off by writing out the first factors, the other factors that we will not be factorizing further because they are part of the factors, or they are some of the factors of the original expression. Now, to factorize that difference of 2 squares, we start off by writing 2 sets of brackets. A plus sign goes into the one set of brackets and a negative sign into the other set of brackets. Now, to obtain x to the power of 4, we say x to the power of 2 squared, which is exactly the same as saying x to the power of 2 multiplied by x to the power of 2. Therefore, grade 9s, the first term in each set of brackets is simply x to the power of 2. And again, we can get 1 by saying 1 times 1. We have therefore factorized that second difference of 2 squares successfully. But we look at this expression again. Do we have another set or difference of 2 squares? Yes, we do. So we can factorize further. Again, we start off by writing down all of the other factors first. Do not leave them out. Now, to factorize that difference of two squares, we write out two sets of brackets, a plus sign in the one and a negative sign in the other. To obtain x squared, we simply say x multiplied by x. So the first term in each set of brackets is x, and the second term in each set of brackets is 1. Do we have another difference of two squares? Fortunately not, so we are done with the difference of two squares. Do we have any trinomials? No, we don't. Any other highest common factors? No, we don't. So at this point, grade 9s, we are done factorizing as far as possible, and we can move on to question B. Question B requires us to factorize the expression that you can see displayed to your screen. As always, we start off with the highest common factor. I'm sure you're very tired of me saying this, but it's so important, and very often learners forget about it. Now, if you look at that expression, it looks as though there's nothing common, no highest common factor at all. But if you look very carefully at what's contained inside of the two set of brackets, you may notice that there are things that are similar. We have an a and a 3 in both sets of brackets, except in the second set of brackets, the a and the 3 are both negative. So how about we sort that out by using the sign change rule? And of course, once we are done using the sign change rule, we might be able to identify and factorize out a highest common factor. Now, the next step that I'm going to do is not a necessary step, but I find that it makes things a bit easier. We start off by writing out the first part of the expression. And now the negative a and the negative 3, I'm going to move around. I'm first going to write negative a and then negative 3. Because when I do this, you can sort of see more clearly that what's contained inside of the brackets is similar but not the same. The difference is the signs. So now we can use the sign change rule in order to change the signs. So what we do is we take out a negative, the positive 4 in front of the second set of brackets is multiplied by a negative. And what's contained inside of the brackets will be divided by negative. We're taking out a negative 1, and we do so by multiplying what's in front by the negative 1 and dividing everything inside of the brackets by negative 1. This is the sign change rule. So we start off by writing out the first part of the expression. Then positive 4 multiplied by negative is negative 4. Negative a divided by negative is positive a, and negative 3 divided by negative is positive 3. We've successfully used the sign chain rule. And at this point, you might be able to identify a highest common factor. Can you see that what's contained inside of the brackets is exactly the same? So those brackets, what's contained inside of those brackets is our highest common factor, and we can factorize that out. When we factorize that out, we divide the first term and the second term by the highest common factor, of course, and we are left with a few leftovers, which are a squared and negative 4. Those leftovers we are going to write out in a second set of brackets. At this point, we are done factorizing by taking out the highest common factor. And of course, we still need to go through that list to make sure that we factorized as far as possible. Do we have a difference of two squares? Well, if you look at the second set of brackets, you may notice that we have a negative sign and we have two perfect squares. So yes, we have a difference of two squares. Let's factorize that difference of two squares. We start off by writing a plus 3. Then we write out the two sets of brackets, a positive sign in the one set and a negative sign in the other set. To obtain a squared, we say A times A. To obtain 4, we say 2 times 2. And therefore we have the first terms and the second terms in each set of brackets. We're done using the difference of two squares. The next question is, do we have a trinomial? No, we don't have any trinomials. So we go through the list again. Do we have a highest common factor? No, we don't. Another difference of two squares? No, we don't. Any trinomial? Of course, we don't have a trinomial. So at this point, grade 9s, we have factorized as far as possible and completed question B. We're now on question C, which is the last problem contained in this video. Well done for making it so far, grade 9s. Of course, whenever we factorize, we start off by looking for a highest common factor. But here we have a trinomial. And if you look carefully at that trinomial, you will notice that there's something strange about it. It doesn't quite look like the trinomials that you are normally given to factorize. Instead, we have the variable squared at the end, the variable to the power of 1 in the middle, and our constant is the first term. So how about, to make our lives slightly easier, we start off by changing this order. We're simply going to use the commutative law of addition, which means that we must keep the signs with the terms. And therefore, if we switch this around, we end up with 2y squared minus 4y minus 30. Notice that I did not change the signs of each term. This is very, very, very important, grade 9s. So now that things look a bit better, we can start to factorize. Starting off with the highest common factor. If we take a look at the coefficients and the constant, you will notice that there is a highest common factor that we can factorize between them. We notice that there's a y, but that the y is uncommon, and therefore the highest common factor is simply 2. In all of these problems, we've had a highest common factor that is just a constant. But please remember that the highest common factor will not always be a constant, and that is why it is so important that you be sure to watch the video about factorizing using the highest common factor. Now that we have the highest common factor, we take the first term and divide it by the highest common factor so that we are left with y squared. We take the second term, negative 4y. We divide that by the highest common factor, and we are left with negative 2y. And then we take the last term, negative 30, and we divide that by 2, and we are left with negative 15. We have now taken out the highest common factor, and we can move along that list. The question is, do we have a difference of two squares? Well, we don't have a difference of two squares. Do we have a trinomial? Well, if you look at that expression contained in the brackets, you will notice there are 3 terms there, and therefore we do have a trinomial that we can perhaps factorize by making use of the methods that you would have learned about in the videos on factorizing trinomials. As always, we start off by writing out the factors that we are not going to factorize further, which in this case is the 2. Do not leave that 2 out in your final answer. To factorize our trinomial, we start off by writing out 2 sets of brackets. To obtain the first term in that trinomial, y squared, we say y times y. And therefore y is the first term in each set of brackets. Now comes the tricky part, or the exciting part, where we need to decide on the signs that we will use inside of the brackets. To do so, we look at the last term, the constant. Can you see that that constant is negative? The fact that that is negative means that the signs contained in the brackets will be different. One sign will be positive and the other will be negative, and we can write that down immediately. So what does the sign on the second term in that expression mean? What does it tell us? Well, we have a negative 2y as the second term. That negative tells us that the bigger of the two factors that we will put inside of the brackets must get the negative sign. So now we're going to look for factors of 15, which of course when we multiply together will give us 15. But when we add them together, we must get the negative 2, which is the coefficient on the second term in that expression. Factors of 15 include 1 and 15. When we say 1 times 15, we end up with 15. We can also say 3 times 5, because 3 times 5 will give us 15. Now we need to put signs on those factors. Of course, since we have the second term as a negative term, we know that the bigger factor in the set must get the negative sign. So we put a positive on the 1 and a negative on the 15, because 15 is a bigger number than 1. We put a positive on the 3 and a negative on the 5, because 5 is a bigger number than 3. That's what it means when we say the bigger factor gets the negative. Now we need to see which set of factors, when added together, will produce that negative 2, the coefficient on the second term. We start off with positive 1 minus 15. That gives us negative 14. Negative 14 is definitely not negative 2, so that set of factors will not work. Let's now try the other set of factors. Positive 3 minus 5 gives us negative 2. We now have the set of factors that we can use. But remember, the order here is very, very important. The 3 must get the positive sign, so we put it in the set of brackets that contains the positive sign. The 5 must get the negative sign, so we put it in the set of brackets that has the negative sign. At this point, we have factorized our trinomial successfully. And of course, we don't stop here. We go back through that list and ask, do we have any highest common factors? Another difference, or any difference of two squares to factorize? Another trinomial perhaps? No, we don't. And therefore, we have factorized this expression as far as possible. Grade 9s, thank you so much for watching this video. It's very important that at this point, if you have not yet, that you download the worksheet from the Junior Techie website and that you use it to practice, because the more you practice, the better you will get at factorizing. Thank you very much for joining me once again. I really appreciate you using your time to ensure that you understand the work better. Good luck for any exams or tests that you may have coming up.